Right, so this episode we're going to look at how to create an SQLite 3 database to hold all the data that we need for the monogame version of Dungeon Master. So we looked last episode at the various files that we need to take care of and so I've done it as a Windows Forms application so that we can have a bit of a GUI to show us what's doing. So this is in the design mode. So we've got a few buttons here and a display panel here. So let me just run it for you so that you can see what it actually does. Let's get the code out of the background here. So this is now running and is connected to the database that I was showing you earlier. So if I click, for example, on the DB items database here, it will show me. We can't directly edit it from this point. It was just really to show you what was in each table. So you already saw that in the DB browser that comes with SQLite 3. And then we've got the champions and so on. So we've got everything is displayed here. Now you'll see down here there's one that's greyed out. This is the one I was mentioning in the last video, where to complete the wall decorations coordinates, but as we only needed it once, I left it in place, but it's greyed out, so we don't need to press on it. There's a button at the top here that says recreate with all data files. What that will do is to delete the database and then go through all of the text files that I was showing you earlier, these ones here, go through them all and recreate the database from it. So there's no point in me running that now because it just takes a few minutes to do it. Also, we've got the ability to update an individual table. So for example, if I realized I'd made some error and in the drawings and that I had to move them or resize them or add new ones or whatever, so that I recreated the XCF file, then that was in turn was passed through the XCF to CSV Reader, which recreated the CSV file, and then I would need to update the database for that specific one. So that's how it's kind of laid out. So we'll get started on showing you how that all works. NuGet package here, let me just quickly check. So tools, NuGet package manager for this solution. The reason I chose this particular one is that it's very clever. You can create a table. So let's take, for example, the champion table, and then using SQLite from that package, you can then put in a primary key. For example, it's an ID here, it could be a name, it could be anything, and then you just put all the properties in that you want to get. So in the champion one there's quite a lot. It doesn't cover all of the hundreds of properties that champions can have, if you remember way back when I was showing you in the console version, but it's got enough here to pick up what is available when you first create the champion. So if we look at the champions one here, champions.txt, yep, there we go. So this was if you look at the kind of each individual champion, there's certain objects that we would need to have, like name, ID, title and so on, and then some of the different sort of values that we would need here. So if we come back to that, now I've got in this one these values here, which are reincarnate values. In other words, when you're selecting your champion, if you select the reincarnate, then it stores here what their kind of values are, whereas if you choose resurrect, it would be using the ones up here. So I had to kind of account for that. The coordinates is much simpler. We've just got name, X and Y. Items, again, we've got quite a lot of things on here, but I just kept them to the minimum for this. Again, we've got a primary key, but the point of doing these is that you can then create the database by simply creating the objects that are on there. So we've got all these different classes which are the equivalent of what we'll be using in the monogame version, but a kind of a simplified version without all the stuff that you can do with methods and multiple constructors and all that kind of thing. So all we need is the basic constructor, which is without any parameters for each of these, and then the kind of constructor that you might want to use to get the data in. So those are all there. So you've seen the design, so let's show you what the actual code for that is. Right, so we're on the form main designer. Now these links at the top here are, I had no idea how to create an SQLite 3 database in C#, so I looked it up, and there was a YouTube series, and this the actual source of the NuGet package here, which were very useful in finding out how to do it. So I'd recommend, I'll put these links in the notes, and I'd recommend in the description, and I'd recommend you have a look at those. So with the main form, the only kind of form level variables we need is the SQLite connection DB, and then these various strings which locate where we're going to get everything from. Now, one last thing which I needed to put in was this dungeon y equals 84. So the reason for having this dungeon y variable here is, if I just show you on the diagrams, on the dungeon itself, this is drawn at coordinate 0, 0 on the sprite sheet here. So all the walls and the decorations and all the stuff that is on top is all drawn relative to 0, 0 on the dungeon. But of course, in reality, this dungeon is sitting here inside it's sitting in that grey area here, and that is 84 pixels from the top of the window when the game is running. So it uses this window here, which is 640 by 480, I believe, and the dungeon itself is here. So that just allows for the offset between the top of the window and the top of the dungeon, where all the coordinates are relative to 0, 0 on this dungeon, not on the window. So that's what it's there for. X doesn't need to be compensated for because it's already at 0. So what I've done, I've put a stop on the form main shown event here, so that we can see what happens when we start the project up. So I'll hit the go button. You saw it briefly flashing up. If I just drop that out the way, we'll see that the form is beginning, has been shown, but of course it hasn't been drawn yet. So let's step in to the initialize one. So it's set this Boolean value to false to check whether or not the config file exists. So it's now going to check whether the file exists, iopaths.txt. It does exist, but I've renamed it to txt.old so that it's temporarily not present. So if we press F11, it'll say no, the file doesn't exist, so create config is true, and then if create config, we're now going to run the function called create config. So let's follow that through. It's using the .NET built-in folder browser dialog. So I'll put another stop on here and we can run this through. You'll notice it's inside a do while loop which forces it to run at least once. So we'll hit F5 so that it jumps into this folder browser dialog here. So you can see our window is now fully drawn behind us and we've got the dialog popped up here. And now this can be, you can alter the layout, you can put the navigation pane in, and I've kept it simple for this. It also says here, look, select directory containing data files, e.g. .txt, .data, .chords. So we can navigate to that. It's clone, I believe. Yep, there we go. Then we've got assets, sprite sheets, data. There we are. That's the one that I know that these files are in. So we'll select that folder. So it's gone through the first one, and now it's going to ask us where the database is to be created. So we'll continue that to run. So we've now got a different one. Now we don't want the database to be created in the assets folder. We actually want it in the Dungeon Master clone, dm clone, bin debug .NET 6 content data, and that's the directory where I want the database to be formed inside the actual game, which of course we haven't yet got onto, but this is the one that I've already done. I'm actually going to hit cancel, and it's come back, so it's going to run it again. Look, so let's put a stop down here somewhere, take that one away. So if every time I press cancel, it just simply redraws it. It's not going to accept that that's where it's coming from. So let's find where it's supposed to go. So dm clone, bin debug net6 content data. That was the folder I wanted it in. Select the folder, and now we've got to type a name for the database. Using this this little box here, which is kind of an input box. If you've ever used Visual Basic, this was kind of built into Visual Basic, but I found a neat little routine on I think it was Stack Overflow that produced this, which is quite nice. So that's the default name, dmdata.db. You can of course alter it, but I'm going to accept that one. We'll press OK. So I'll just show you the input box function that was running just then. It also checks whether you have put inside the name. If we hover over the name is dmdata.db. So if it doesn't contain a dot, then it'll be renamed to that plus db, so that we've got the proper name for our database. So let me just show you that input box. Right, so here's the input box. It's of type dialog result. So I'll see if I can find where I got this from. It is not my code, but it works extremely well. So it just produces a new form with a couple of buttons and a text box and a label on it, and produces that quite neat input box, which I thought was really good. So anyway, that's just show you what it does. So we've got the the database name decided, and now we're going to write that to a text file called iopath.txt. Now of course I've overwritten the original one, so if I just go back to there, I've got this iopath.txt.ol, so I'm now going to continue running this. There we go, so it's now loaded in properly, and if we look at here, we've got iopath.txt has now been rewritten with the same contents as that one originally had. So if I show you what the contents of that are, then you've got the data source, the DB path and the DB name are all in there. Now I've gone a little further than I intended, so I'm just going to stop that and restart it because I wanted to continue with the initialize thing here. So let's do that again. So we can probably jump past that one because I've now put a stop in the initialize routine here. So we've checked whether we need to create the config file. This time we don't because it's now been done. So the next thing to do is to process the text file iopaths.txt. So let's step through that. So the file name is iopaths.txt. Then we're going to create a new empty list and then read all the lines from that file. So let's do that. Empty string, and we've now got these 3 lines, and those are the lines that were inside it. Then it's going to go through each of the lines and check whether it starts with a hash sign or whether the line, once trimmed, is of 0 length. This won't apply to this particular file because all the lines have got relevant data in, but it's the same process text file is used on all the data files in turn to kind of clean them up before they're processed. So it goes through, and as long as the each line doesn't start with a hash sign and is not empty, then it will add to the string. So this will run through 3 times. That's it, and the return value is of course a list with exactly the same data in it as the original array. So it's kind of cleaned it up, and we'll be using the same process text file at a later date. It now checks whether the count of those lines is not 3. If it's less than or greater than 3, then it means we've got a corrupted or missing file, and you'll get the message box showing. Otherwise, it's now going to read through all the lines and extracts the data source, database name and database path from it. So this kind of procedure of going through the lines is repeated many times in the file as a whole. We went through a very similar process in previous videos on the XCF data. So I'll just quickly go through just so that we can show how it's done. So going through each of those 3 lines in turn. Now the decode data is just a kind of a split, but I've done it as a function decode data so that we can choose what character we're going to use to split the line. So the line itself, look, is data source equals C and then the location of it in my Dropbox. So I want to split it at the equal sign on there. So let's pass that through to decode data. So the separator here is the equal sign, and that's the line that we're going to split. So all we do is split it using that separator and removing the empty entries, and that will be returned back to here. So our string data now consists of the data source and the path, which is exactly what we want, of course. Then it's going to check whether the path exists, and if it doesn't exist, then we're going to set the create config because there's obviously something wrong with our config file, else it makes the data source equal to that. So the data source is now set to that path. Next is going to check if the data 0 is db path. I don't think it was. Let's just check. It was data source. So we're just checking if it's data source, whether it's db path or db name. So in turn we will check all through these to get the data out of it, and then assuming that everything's passed the tests here, then we go down to the bottom here. So let's put a stop there and we'll F5 to that. So the database path and file, which is empty, is to combine the path and the name, which is dmdata.db. There we are. So the database path and file name is the all this lot here ending in dmdata.db. So we are now going to move on to check the database. Let's follow that through. So what we're doing is to check whether that file, the database file dmdata.db, exists. If it doesn't exist, it's then going to create it by doing the following list of functions here. I'll just F11 through because ours does exist, so it's going to simply open it. So assuming that it didn't exist, what it would do is would create, because it doesn't exist, it would create a new database at that destination with there called was it dmdata.db, and then it would create these 1, 2, 3, 4, 5, 6, 7, 8 empty tables, all of which are based on a class. So this is the clever thing about this using this particular NuGet package, is that you can just create the table by giving it the class name, and the empty tables are created. As it happens, this is already there, so it's going to open it, so we'll go through that. Now we're going to fill up the list box, which, if I can bring that forward, yeah, that's this bit here. We're going to fill up the list box on there. So we're going to first of all clear the list box items, and then check, does that path and file exists? It does. If the table exists, db item. Now, how do we check whether a table exists? We've had to use a bit of SQL here, so let's go through and check whether that works. So we're going to check whether the db item table exists. Now we have to use this table mapping thing here, and so we are not trying to map to a specific table, we're just mapping the whole database type. And then we set up this new object. I'm not entirely sure how it works, but it does. So if anybody knows and can put it in the comments as to how this actually works, then great. But so you create this empty base sort of object, and then you use that in the query. So what we're doing here is we're trying to get the table count, is the database query using the map of the whole database. I don't know if it would show anything here. Oh, that's interesting. So it's showing us the columns, the flags, primary key, insert. Okay, yeah. So I'm kind of getting some idea of maybe how this is working now. Yeah. Okay. So it's selecting from the SQLite master, which is the kind of the master table, where the type equals table and the name is the table name, which is db item, and then it passing this weird object here, which we don't know what it does, dot count. So we can press F11, that runs the query, and the table count is 1. So if it was 0, it would be returning false. If it's 1, it returns true. Otherwise it throws an exception that there's more than one table by that name. So obviously that we now know that that table does exist, and then we're going to add the db item string db item to our list of tables. Let's see if that has popped up. Probably not at this stage. No, we'll need to run it all through first. So let's take it to the end there and run all of that. Continue, and then F11 from here. So we filled the list box, check database is finished, initialize is finished, and we're now just sitting waiting for everything to happen. So let's press the button, and there we go, we've got our database tables all listed in the list box. We've got our empty data grid here and a list of all the tables with the buttons that we can do stuff with. So we can recreate the entire database, or we can add individual tables as required. So let's, before we look at these buttons, just show what happens when the list box here is clicked on. So let's click on the top one here. So I've put a stop in the list tables click event, so we're clicking on the list, so we're going to display the table. So let's run that. So we get the table name from the text, which is DB item, and then we're checking which table name we have selected. DB champion, no, it's this one here, so we'll step through those. DB item, then the data source of our grid, which is currently null, is set to the table DB item to list. You have to use this to list to get the thing to display there. It took me a while to work that out, but so we're checking through, getting all the stuff from there. Anyway, let's continue, and we get the DB item is now displayed in the table here. So we've got everything here. This is not currently set up to edit anything, it's just there purely to demonstrate that the database has been produced. You've got what you were looking for. So the next thing to do is to show how one of these buttons works, so that we can see what happens when you actually want to change some data. So we'll update, let's choose the coordinates table. I've already put a stop on that one, so if we press add update coordinates table, again it's stopped on the event handle here, so we're going to add coordinates. So let's press F11. Now what we're looking for is, let's just find the relevant files. Not that one, no. That one. Okay, so in our data area where the sprite sheets produce the coordinates and so on, we've got some with the file extension chords, COORDS. There's others with data, and there's simple text files and so on. So this particular one, add coordinates, is looking for anything that has the .chords file extension. So we're going to check this through. The replace is true, so that means we're going to replace the table. So we're going to set the cursor to the wait cursor, and if replace is true, we're going to check whether the table exists. We've already been through the table exists method of how it checks whether it is, so we know that that does exist. So let's move on. We're now going to just simply drop the table. It's now dead, and we're going to create a new DB coordinate table. Simple as that. And now we're going to go through each of the file names in image paths. Now image paths is up here, which is a list. There we go. And so we've got champions, doors, floors. Well, as you can see for yourself there, these are the different text files that we're going to find. So we want champions.chords, COORDS. So we're going to go through each of those in turn, So the first file name we found is champions. So we're going to check whether champions.chords exists, which I think it does. Let me just find the data. Where are we? Chords. No, that one doesn't exist. So it will skip that one because it says if the file exists. So the first one that does exist, I think, will probably be doors. So let's skip that. No, that one's gone. What are we looking now for? Doors. Yeah. So it's finding doors dot chords, and then as before, it's going to process the text file, which I will now show you. Where are we? There we go. So we're going to look at doors.chords. Let's just drag my Notepad++ window away from the other screen. There we go. So this gives you the door coordinates. So it's a relatively simple file. It's got a comment at the top, so that will have to be removed by that process text file. And then we've got some data in the grid here. This relative equals true at the top here tells us that these coordinates are relative to the dungeon. Therefore, we would need to add on that y coordinate to create the kind of the finished result. We want to add that y coordinate on to whatever has been set in here. For example, the y value here is 40. For quite a lot of the things, we would need to add 84 to that when processing this this file. So we're going to look through. We're going to process the text file, which I've showed you before. So we'll skip past that. So we've now got the lines with 47 lines in it, which is the ones I just showed you. And then it's giving a is relative Boolean value here set as false by default, and then we're going to go through each string of lines. If it starts with relative equals, then we can work out whether the is relative equals true or false by checking the substring of that line, and then once we've determined whether it's a true or a false relative one, we can, because that's always, if I just show you here, the relative bit is always at the top of the file. So that's the first line that will be read. We will know whether it's relative or not for all of the following data. So then for each of the lines, we're going to decode the data again by splitting it using this time the comma, so that it will give us the data that we need. So if I put that back up again, so we've got metal.c2, comma 15757. Not quite sure what that minus is there. Maybe I accidentally put that in. Let me just get rid of that. Yeah, we'll save that. I suspect that was me playing with a keyboard. It definitely shouldn't have been there. Okay, so we're going to go through the data, and let me just check actually whether that line has got no, it hasn't. There is no minus sign in the, yeah, it must have been my error there. So we're going to go through all of those. So the first one we don't need to deal with because that just checks whether it's the relative it is, and the relative is true in this case. So we'll go through the next line. So we're going to split the line which says wood.c3 123, 40 using the comma one. So there's our data, which is now split into three parts. We've got wood.c3, view 123, 123 and 40 are the two x and y coordinates there. And now we're going to try pass the data 1 and data 2, the two strings that are currently holding the coordinates, which is 1, 2, 3 and 40, and as long as we can pass them out into integer values, then we can now check whether we need to add. So x has now been set to 1, 2, 3 and y has been set to 40. If it's relative, which it is, we're going to add onto our y value, which is 40, the dungeon y, which is 84, making it 124. Then we're going to insert this a new db coordinate class. We're going to insert into that the all the data that's in there. So data 0 is of course wood.c3, and then we've got our adjusted values for x and y. So we're going to create a new db coordinate object using woodc3, 1, 2, 3 and 1, 2, 4. So it's setting the data into the class here. Class has been created. We're now going to insert it. So we pass the object, which is our new class, and insert it into the database. Okay, it's obviously going to go winding through all of them, so I'll let it continue with its journey. And this little message pops up, coordinates added to the database. Okay, and there they are. So I won't go through all the other buttons here. They all do pretty much the same thing. They load in the relevant data file and convert it into a database. So hopefully that's given you some idea of how this works to create an SQL-like database from a bunch of different text files.